a subject is not a difficult subject. It's a very straightforward subject. It is a science subject which requires critical thinking. It requires you to think. So that is why I always advise my students to look at physics as a technical subject. So I'm going to explain this in a nutshell. Okay. Now, physics actually deals with only two basic ideas, two basic concepts fused together in physics. Okay, physics have been reduced to do two basic ideas. One of those ideas, one of those ideas is energy, and the other one is matter. So physics deals with only matter and energy. So once you understand matter and you understand energy, no matter the examination, these are the two basic concepts that makes physics. Now I'm going to be revealing each of these to us. We are going to journey through the various topics in physics in this lesson as you prepare for this exam. Okay, the best way to conceive and understand physics, so that when you get to the exam hall, instead of getting yourself worried, you just understand the concept. Now we are going to start from motion. Motion. Now, what is motion, for instance? Okay, motion is simply movement. You see that? So that is physical. That is energy. So there is energy involved. So once you have energy involved and there is matter, you have already achieved what you are achieving. Okay, what you need is to understand the relationship between matter and energy. Now, energy is the ability to do work. You see that? Which means without energy, you cannot work. You can see the relationship between the both, right? Energy and work. And you need matter. Yes, for instance, if you don't put fuel in your car, the fuel is the matter. That fuel you put in your car is the matter. Is that taken? Then the fuel will now be converted to heat energy, from which it will now be converted to mechanical energy. And that is where motion is coming into place. And these are conversion of energies. So matter has been converted to what? Energy. From the fuel of your car, it has been changed into what? Heat energy. And consequently, mechanical energy that can now power your vehicle. I'm sure you can see what is going on there. So that is how energy is all about, okay? Physics is simply the transformation from one form of energy to another. For instance, let's look at motion. Okay, motion is movement, right? Good. Now, what are the parameters in motion? We talk of velocity, acceleration, all of them, both the vectors and the what? And the scalar quantities. Now, let's go to another topic, like vector. Now, what is a vector? A vector is any quantity. A vector is simply a quantity that can be described with both magnitude and what? Direction. Now, when you have a concept that has both magnitude and direction, they are simply vectors. So why? Because you, without describing their direction, you cannot call it a vector. You cannot finish describing that quantity. I'm going to explain this. Now, most of us travel distances. We travel longer distances. Now, when you travel such distances and you have to locate somebody in that distance, you have to understand the direction of the person's location. If you don't understand the person's location by understanding that direction, then there is no way you can locate that person. I'm sure that is clear. That is physics. And to do that, you need the displacement. That is where displacement comes into play, right? Then let's look at force. Force is a concept in physics. Okay, force is what causes energy to be converted from one form to another. The forces of nature causes, for instance, when an object is at rest, it is potential energy. It has potential energy. Then when that object is now pushed or pulled, what happens? The potential energy is converted into kinetic energy. Can you see that now? So there is this change, constant changes. Now there was this topic, I think it was under potential energy and work, that I was discussing with my students yesterday. Yes, just yesterday, because I have a student that is preparing for post-UTME. Now, there was this question that states that an object is lifted or is held at a position H above the ground. Then we are now told to calculate the work done. Now, the student was thinking, okay, work done is equals to mechanical energy, that is gravitational potential energy. But the object was held at a distance h above the floor. We were not told that the object was moving, so the object did not move. The implication is that the object is at rest, and when an object is at rest, the work done is zero, because the object is at rest. So when an object is at rest, the work done is what? Is zero. All right, so thank you for that. I appreciate you. So that is what we are actually saying. Physics is a very interesting subject. Now let's look at electromagnetism. What is electromagnetism? Electromagnetism is the relationship between electricity and magnetism. Electricity and magnets. Now, some of us don't know that when a wire is carrying current, okay, there is a wire and current is flowing through the wire. Some of us do not know that there is magnetism, there is magnet around the wire. Yes, the wire can attract another wire that is carrying current. Do you understand? So in electromagnetism, there are 6 basic laws. Yes, and you need to understand this concept in physics. These basic laws are talking about energy, right? Matter and energy. There are 6 basic laws in electromagnetism, and I'm going to show you this 6 basic law in this live stream. So that's why I want to stick to the end. Now let's proceed. Where are you? Oh, thank you very much. You're asking me where I'm from. I'm in Nigerian, okay? I'm in Nigeria, okay? Now, there are 6 basic laws. These laws are: 1, we have the Ampere's law of current. Ampere's law of current is a very popular law, but most students do not even know that law. Ampere's law of current. Now, if you have 2 wires, okay, 2 wires carrying current, what Ampere is saying, oh, law from India, thank you very much, thank you, I appreciate you. Now, when you have 2 wires like this, 2 parallel wires, and they are carrying current, all right? So once they are carrying current, now if the currents are flowing in the same direction, if this current is flowing like this and this one is flowing like this, the 2 wires will attract each other. You see it now? That is what Ampere is talking about. So which means as the current is flowing, there is magnetism around the wires. This is the reason why government says that nobody should don't build around an overhead cable, because if you do that, as the current is flowing, what happens? Magnetism is around that wire, and if that happens, it affects our brain, and it affects our hearts too. So that is why we are told not to trade or live around current carrying conductor like overhead cables. In most countries, the wires go above the head, above people's head, just like in Nigeria too. That is how it happens, okay? So you are not to stay close to high tension cables, because these cables have electricity around them. And when the electricity is flowing, according to Ampere's law of current, there is magnetism around a current carrying conductor. And when this happens, there might be attraction if the current flows in the same direction. And if the current is flowing in opposite direction, there is what? Repulsion. That is what Ampere is trying to say. Okay? Please, if you want to ask me question, don't worry. I'm already here. I did not set a separate place for questions. Please bear with me. Now, the second law after Ampere's law is Fleming's left-hand rule. Fleming's left-hand rule. I'm sure you have seen something like this. Look at my fingers. I'm sure you can see my fingers, right? Can you see what I'm doing now? This is my fingers. So the fingers are held mutually perpendicular to each other. You can see this one is perpendicular to this and is perpendicular to this. This is the right hand rule. Okay, why this other one is Fleming's left hand rule. You can see it. This is Fleming's left hand. This is the right hand rule. Okay, this is the left hand rule rather. Why this is the right hand rule? Each of them are used for generators and motors. So we have one for generator and one for motors. Okay, according to Fleming's right hand rule, each of these represents, one of them represents field, one force, and one direction of what? Motion. So this is what you need to understand. So that is, I have named 3 laws now. Number 1, Ampere's law of current. Ampere's law of current states that when current flows through a straight wire conductor, when current flows through a straight wire conductor, or when 2 straight wire conductors are parallel and current flows through them, they attract each other if the current flows in the same direction. But if the current flows in opposite direction, they repel each other. That is exactly what Ampere is trying to describe by his own law. Then we have the Fleming's right hand rule and the Fleming's left hand rule. Then we also have the right hand grip rule. Yes, we have the right hand grip rule. It's like this. I don't know if you have seen this before in your book. When you grip an object, a long conductor, when you grip it, your hand is like this. Now, what this law is saying is that if a straight wire conductor is gripped with the hand, like this, is gripped with this hand, such that this one is coiled like this. Can you see it? So this finger, this thumb, represents the direction of current. Then according to the right hand grip rule, this coiled hand will represent the direction of the magnetic field. That is what it means. So this one also applies to what? Overhead cables, which is the more reason why we are told not to trade around overhead cables. I hope this is clear. Please, let's be well guided so that we don't get used to all this. They are not too good for us. So thank you very much. Yes, I understand. I can hear you. I understand what you have said. So one question, can I ask? Yes, you can ask your questions. Okay, yes, you can ask your question. Then Coulomb's law from India. Thank you. Then the other law, okay, the other law is the law of electromagnetic induction. I'm sure you have heard of the word electromagnetic induction. There are 2 laws under electromagnetic induction. Now, what is electromagnetic induction? The word electromagnetic. So it means electricity that is produced from magnetism. So electricity can be produced from what? Magnetism. In what way can electricity be produced from magnetism? When you have a magnetic field, maybe you have 2 magnets placed side by side, 2 powerful magnets placed side by side. In between the magnets, there is an electric, or there is a field, a magnetic field. So if you look for a conductor and use it to disturb that field, you can generate electricity. That is electromagnetism. Now, there are 2 basic laws under electromagnetism. Now, I'm going to show you these 2 laws, okay? And the man that discovered electromagnetism is called Michael Faraday. Okay, Michael Faraday was the man that discovered what? Electromagnetism. So what he was trying to say is simple. Some of us may not understand this, but I'm going to show you in this live stream. Please, if you are watching me and you are not subscribed, please go ahead and smash the subscribe button, please. Smash the subscribe button so that YouTube will always notify you whenever I am coming to dish out content. So thank you very much. I can see majority watching, but I'm sure that most of us are subscribed. So thank you very much. Now, what the man is trying to say, the person of Michael Faraday, he said that whenever there is a disturbance in the electric field or in the magnetic field. Okay, whenever there's a disturbance in the magnetic field, linking a circuit, okay, linking a circuit or linking a conductor, an EMF is induced. That is electromagnetic induction. So an EMF is induced. That's what he said. Then the rate at which this EMF is induced or produced in the conductor is dependent upon the rate at which the field, the magnetic field, is disturbed. That's what this man is trying to say. So we need to understand what the man is trying to say. Okay, so I can see your long question. I will read it, don't worry. Okay, now according to this man, the person of Michael Faraday, he said that, for instance, in our generator, you understand the way generator works, because it's a mechanical stroke magnetic stroke electric process. So there are three energy conversion in our generator. One, we will go and buy fuel. When you buy fuel, you fuel your generator. When you fuel your generator, that is chemical energy, and the fuel is matter, and the matter is meant to be burnt inside the generator. You see that now? So the matter will be burnt inside the generator, and when it is burning, it produces what we call heat. That is energy. What has happened? What happens is that the chemical energy, okay, the chemical energy in the fuel have been converted into heat energy during burning. Please do well to like this video. Okay, do well to like it. I will appreciate so much. Okay, so the energy in the fuel have been converted through burning to heat energy. Do you see that now? Then that heat, it does not stop there. What your car needs to move is not the heat. Okay, it needs some force, and that force has to be mechanical. So the heat is then converted through the piston of the engine, okay, that now moves the car. Do you understand that now? So that's exactly how the system actually works. I hope it's understood. Now let's go to the second law of electromagnetism. Okay, don't worry, in my next live stream, I'm going to use practical. Okay, I'm going to demonstrate this practically. Then the next law is called Lenz's law. Lenz's law is related to what you call the law of conservation of energy. Yes, according to Mr. Lenz, he said that, you see that EMF produced during, when we are stating the other law, the Faraday's law. So that EMF that was produced, Lenz's law said that that EMF that has been produced, or the induced current, flows in a direction that opposes what is producing it. Yes, I'm going to explain it in my next slide. Don't worry. Okay, what it means is that the process that is producing the magnetic, that is producing the electricity, okay, is being hindered by the EMF that is being produced. So let's state Lenz's law. Lenz's law simply states that the induced EMF or the induced current, please, I'm sorry for the noise, okay, in case you are hearing some noise, because I'm close to the roadside. Now, the induced EMF or the induced current flows in such a direction as to oppose the change producing it. That is what it is saying. Okay, so okay, I'm in a G advanced aspirant. Okay, it is the toughest exam in India. Yes, I'm aware of G. I'm going to be making videos on G, don't worry. Okay, both in maths and other areas. Just let me know, DM me. Okay, my WhatsApp is there, my WhatsApp page is there, so just DM me. I will see you one-on-one and we can talk about that. Okay, now what are we saying? The EMF produced according to Lenz flows in such a way as to oppose the change producing it. Do you understand? And that is what brought the idea of eddy current. Now, what is eddy current? Why can't a charged particle at rest emit electromagnetic waves, whereas an accelerating charged particle can? Yes, don't worry, I'm going to explain that. Yes, just ask your question, I'm going to explain. But let's proceed first. Now, that is what leads to what we call eddy current. Now, what is eddy current? Eddy current is simply see a current that flows in a circle. When a current flows in a circle, it is called an eddy current. Is that taken? So then what happens to that eddy current? You know, current is supposed to flow from one point to another. But eddy current does not flow from one point to another. It circles, it just flows in a circle, producing heat and wasting energy. Do you get that now? Imagine you have current flowing around from in each of your circuits. Okay, you see current flowing around. What does it mean? It means there is energy wastage. And it is eddy current. It is called eddy current. Okay, so we try to avoid eddy current by doing what? By perforating the plates. Okay, perforate the plate. Yes, the conductor, perforate it. All right, that process is called laminating. Yes, you are laminating, you are producing holes. Once there is a disjoint, once there are holes, there are gaps, current cannot flow. That eddy current will not be able to move like this again. Okay, so it will be impossible. What happens is that the current will not be flowing straight. The one that would have diverted will not find a space because there will be a gap. That is what we are talking about. I hope these are well understood. Now let's proceed. The 7 laws of electricity and magnetism put together. 1 is Ampere's law. Okay, it's not 7 laws. I think about 5 or 6. 1 is Ampere's law of current. 2 is right hand grip rule. 3 is Fleming's right hand rule. 4 is Fleming's left hand rule. 5 is Faraday's law of electromagnetism, and 6 is Lenz's law. So I think there's about 6 of them. So if you know this, you have captured the entire electromagnetism. All right, you have captured it. Why can't you? Okay, is that taken now? So once you know these 6 laws under electricity and magnetism, you are done and you are good to go. All right, so thank you very much for for your nice commendation. I appreciate you. Now let's proceed to the next one. Let's look at radioactivity. Yes, somebody discovered radioactivity and the person used uranium. Do you know that radioactivity was discovered by accident? Oh, some of us don't know. We think that somebody just went there and discovered radioactivity. Radioactivity has caused many harms in the past, even before it was discovered. Yes, so somebody discovered radioactivity. Please let me know in this live stream if you know the person that discovered radioactivity. Okay, I'm going to say it at the end of the live stream. Okay, but before then, let me know who discovered radioactivity. Now, what radioactivity was discovered by accident. The scientist that discovered it, I'm not going to name it now. Okay, I will name him later. He was observing a particular element or observing elements. Then later, yes, uranium is more radioactive. Yes, the person actually discovered radioactivity through uranium. The person discovered that uranium was able to blacken a particular sheet. Okay, it was able to blacken it. Yes, it causes it to fluoresce, all right, or cheer. So then he now took uranium. He took a sample of the uranium to the laboratory. Then from there, he discovered that there's something strange is coming out from uranium. You see? And that was how radioactivity was discovered. Is that taken? Now, what is radioactivity? Radioactivity is simply the emission, okay? Yes, the emission of radiations from some unstable nuclei, okay? And consequent decay or breakdown of this nuclei because they are unstable. That is what radioactivity is all about. Please like my stream. You can do it to subscribe. Okay, I'm going to give you updates here and there. Okay, once in a while I'll be coming as much as possible. Now, radioactivity emits particles. If there is no decay, there will be no emission of particles. So, what are the particles or radiations that are emitted? Yes, there are 3 major particles that are emitted. 3. I'm going to name them in this live stream. The number one particle that's emitted during radioactivity is called the alpha particles. I'm sure we are aware of alpha particle. It is the heaviest of them all. It is the heaviest particle. Okay, it consists of streams of fast-moving nucleus or nuclei of helium. All right, that is what it consists of. So please don't forget that. Then alpha particles have their characteristics. One is that they are positively charged. Alpha particles are what? Positively charged. All right. So thank you very much. I appreciate you. I will reach out to you. Don't worry. Please. So alpha particles are what? Positively charged. Yes. How do you know that they are positively charged? Put them in an electric field. Okay. Yes. If you put them, if you put a radioactive material, let's say uranium, okay, and it's emitting radiation, and that radiation is alpha particle. If the particle enters an electric field, since it is positively charged, it will be deflected to the negative part. Do you understand? Because positive and positive will what? Repel. So there will be a repulsion from positive to positive. So it will be attracted to the what? Negative part or negative plates of the electric field. That was how scientists were able to analyze that alpha particle is positively charged. Then what about beta particles? You see, it is negatively charged. Now let's discuss many things about alpha particles. Remember, alpha particles are positively charged and they are heavy. Okay, and because they are heavy, they cause a lot of ionization. Okay, they cause a lot of what? Ionization in gases. So, and there are a lot of other properties of alpha particles. Okay, then let's look at the beta particles. Beta particles are negatively charged. Yes. How do we know that beta particles are negatively charged? Because they are deflected towards the positive part. Okay. Yes. Since remember, negative and positive will attract. So when something is positively charged, it will deflect to the negative part. And when something is negatively charged, it will be attracted to the what? Positive part. So that is how to analyze whether it is positively charged or negatively charged. Just remember your magnet and the rest. That is how it is done too. Okay. Then the next one is gamma radiation. Gamma radiation. What is gamma ray? A gamma ray is simply an electromagnetic what? Radiation. Yes, gamma radiations do not have mass number or what you call atomic number or so. You understand? So they are just normal radiation. They are not difficult. They are just normal radiation. Just see it as normal radiation, like light. Okay, like X-ray. All of them are like that. That is how gamma radiation is. But one thing about gamma radiation is that it is highly penetrating. Yes, gamma radiation is highly penetrating, unlike alpha and beta particle. So gamma radiation is the most penetrating emission of alpha of radioactivity. Is that taken now? So please take notes. Okay. So sir, can you explain in smart board? Okay, I'm going to explain in my next live stream. It's just an introduction. Okay. Please take note. I'm going to explain in my next live stream. I will go through all these topics before the examinations you have, including those that are writing G and so on. Please do well to subscribe, so that you don't miss my next live stream, because I'm going to explain these topics in details. I'm just giving you a summary analysis of all these topics. Briefly, we are going to deal with all the topics. Don't worry. Do well to like and share these videos too. So please don't forget that alpha particles are positively charged. Gamma particles are negatively charged. Okay. Then the radiations, the one we call gamma radiation. Please, they are not particles. Gamma radiation. They have no charge. They are neutral. Do you understand? They cannot be deflected to positive plates. They cannot be deflected towards negative plates. They are just neutral. So they keep moving. This made them to be very penetrating. They penetrate a lot. So we have to be very careful. In fact, a lot of scientists have lost their lives in the process of discovering some of this radiation. I'm sure we heard of Marie Curie and her husband. I'm sure you know Marie Curie and her husband. Yes, Marie Curie and her husband lost their lives from radiation. Okay, yes, because they were actually penetrated by these dangerous radiations and they actually lost their lives. So please, it is very dangerous. That's why we use anybody that's working under radiations, radioactive particles like this or radiations, must protect him or herself. So make sure you protect yourself if you are working in a nuclear radiators. Okay, so now we are going to be looking at decay. Yes, radioactive decay. Radioactive decay is simply the breaking down, okay, of radioactive particles. Yes, and this is based on what we call half-life. What is half-life? Half-life is a function of decay constant. Do you understand? If, for instance, let's explain the meaning of half-life, because physics has to be broken down, and I'm going to do that in my next live stream. Please do well to subscribe so that you don't miss our next live stream. Now, half-life, it's not that it is a life that is half. Half-life is simply the time taken for half of the mass or quantity of a radioactive material to decay to half of its original mass. Do you get it now? Now, if you have a mass of 20 grams, for instance, after its half-life, it will now change to 10 grams. You see that now? So it has decayed from 20 to 10 grams. Then after another half-life, let's say if the half-life is 20 years, after 20 years, it will decay from 20 grams to 10 grams. You see that? That is the half-life. It is not the life that is halved, but it is the quantity that is being halved. So that is what people should understand, what students should understand. I make this easier for you to define it. Then after another 20 years, it will decay or break from 5 to 2.5. You see that? So it will keep going down and going down. So that is what half-life is all about. Okay, I'm going to show you the relationship between decay constants and half-life in my next live stream. Now, let's look at a topic like heat. Yes, you know, most persons don't want to hear that topic called heat. What is heat? Heat is a form of energy. In fact, heat is energy, although it is a form of energy, because energy only exists in different forms. But energy is actually one in the universe. But it can be transformed from one form to another. It can change from one form to another. Remember, there are different forms of energy. So heat is a form of energy. Now, how do you differentiate heat from temperature? Okay, how do you differentiate heat from temperature? I hope you can still hear me. Okay, how do you differentiate heat from temperature? Temperature is simply the degree of hotness or coldness of a body. That's what temperature is all about. The degree of hotness or coldness of a body. That is what temperature is. Okay, so it is different from heat. But there is something unique about temperature. If heat must flow, temperature must be the one to tell heat where to flow to. Do you understand? Now, heat flows from a region of high temperature to a region of low temperature. That is how heat flows. So heat does not flow in all areas. So if you hold a spoon and you are turning your food, after a while, the heat from the food will get to your hand if that handle is a conductor. That is because heat will flow from the hot pot of soup or food to the cooler part, which is a part of your hands. All right, that is how heat flows. Heat actually flows from a region of low temperature to a region of high temperature. That is a law. Is that taken? Now, what about Newton's law of cooling? Newton's law of cooling. We are going to look at vapor pressure, then specific heat capacity. You see that? So then we will look at modes of heat transfer. Let's look at the modes of heat transfer. What are the modes of heat transfer? There are 3 modes of heat transfer. Now we have defined heat. What are the modes? What are the methods in which heat can be transferred? One method in which heat can be transferred is called conduction. Yes, conduction. Another method is called convection. Then the third method is called radiation. Now I'm going to explain each of these methods of heat transfer in a jiffy, just a summary. In my next live, in my next live stream, I'm going to go ahead and do what? And teach it on the board. Now, what is conduction? Physics students should learn this. Now, when we say conduct, there is no movement of the particles during conduction. It's only the heat that is transferred from one molecule or one particle to another. But these particles do not move. They simply vibrate, they oscillate, and then transfer the heat to the next neighboring particle. That is exactly what it is. Okay, I hope that is clear. So conduction is simply the transfer of heat from one end of a conductor to another with the heated particles remaining in position. So the particles are in positions, they are not moving. Okay, don't worry, I'm going to use smart board in my next class. Okay, so the particles are not what? Moving, but the heat is transferred by vibration. So there is this give and take. Okay, I take from my neighbor and give to the next neighbor. So we keep taking from one another. That is exactly how conduction is. Is that taken? For instance, your spoon, I've made an example with a spoon. Do you get it now? Then let's proceed to the next one, which is convection. Convection. Okay, remember we have two types of conductors. Okay, we have conductors rather, and we have non-conductors. Okay, we have conductors and non-conductors. So we have materials that allow heat to go through them. Those materials are called thermal conductors. Then materials that do not allow heat to pass through them, they can never allow heat to pass through them. They are called non-conductors, or you can call them bad conductors. Yes, because they have their applications, but they don't allow heat to pass through them. Is that taken? Now, what are these conductors? One, all metals are good conductors. Metals are conductors because they conduct heat, they conduct electricity. Although their rate of conductivity are not the same, but they all conduct. Is that taken? Then we have electrolytes. Electrolytes are conductors too because they conduct electricity. But in the process, they break down. We are not looking at that. We are looking at their ability to conduct. Is that taken? So that is conductors. Then we also have the semiconductors. We are going to explain that in our next live stream. Don't worry. We will explain semiconductors. Now, the next one is convection. Convection. What is convection? Convection is the transfer of heat. Convection is transfer of what? Heat by the actual molecules, by the actual movement of the molecules. If you are boiling water, have you ever observed the water? When you observe the water, what do you notice? You notice that the particles are moving. The particles are moving. Okay, as the temperature increases, the particles start moving about, right? Yes, the particles are actually moving about. That is, the particles are actually carrying the heat from the hotter region, from the cooler region, okay, from the hotter region to the cooler region. Then the objects or the particles at the cooler region are coming to replace the hotter ones. Do you get that? So that is convection. There are different applications of convections, and I'm going to say that in this video. All right, do well to stay to the end, but I'm not seeing anybody watching now. I'm sure you are still going to join me. Okay, now there are different applications of convection. Cooling fan uses convection. Then a natural convectional current known as land and sea breezes. I'm sure we know land and sea breezes. This is very important. In fact, this is a major question. You will be told to explain land and sea breezes. So it's a major question in examinations, different examinations. Okay, so for those of you who are preparing for exam, learn land and sea breezes. Land breeze occurs at night, while sea breeze occurs during the day. All right, so the two of them are consequences of convectional current. Is that taken? Now, during the day, let me explain land and sea breezes in a very light and simple manner. During the day, when the weather is extremely hot, the temperature is very high, the heat from the sun will increase the temperature. Okay, the sun will heat up the land and also heat up the sea. But which one will be hotter during the day? Can you tell me in the live stream? Let me know the one that will be hotter. Do you know that the land will be hotter than the sea? Go to the sea, go to streams during afternoon. You will notice that the stream is cooler than when you are at home. That's in the land where there are no seas. Okay, so if you go to the sea, it is cooler. The implication is that the temperature of the land is what is higher than the temperature of the sea, and that is during the day. So what happens? The air closer to the land becomes heated. Okay, the temperature rises, so the air closer to the land becomes heated, and once they are heated, they becomes very light, and because they are light, they rise. Okay, they will now rise. Now when they rise, they will go and replace the cooler air in the sea, because in the sea, the air close to the sea is not as hot as that of the land, so which means it is heavier. Okay, so what happens is that the air from the sea, which the air from the land which has been heated, will now move to replace the one from the sea. Do you understand? Then the one from the sea will now come and replace the one at the land. So that is how conventional current is generated. Then at night, the process is then repeated but reversed. All right, so instead of land giving out it's a hotter air, it is the sea that will give out the warmer air. Okay, because the sea is warmer at night. Okay, the sea is warmer at night, so the air at the sea will be warmer than the air in the land. I hope that is clear. So this is how land and sea breezes is actually done. So it's in a very nutshell. Now let's go to another topic. Let's look at a topic like specific heat capacity. Now, what is heat capacity? What is capacity? A student that is preparing for exam, you want to prepare for an exam. Now, the question is, what is capacity? Capacity is simply the ability you have to do something. Okay? Yes, your ability to do something is a capacity you have to do that thing. Now, when you say heat capacity, what is heat capacity? Heat capacity is simply your ability to what? To accumulate heat. Let me explain with this. Assuming you have a set of twins, maybe two children born at the same time, and one can eat. Okay, one can eat more than the other, which means the one that can eat more has more capacity to take in food. All right, that's what it means. Then the one that can eat less has the capacity to take less food. Now, when you supply heat to two objects of different materials, okay, you supply heat to two objects of different materials, the both of them, the temperature of the both materials will not rise at the same time. Okay, the temperature of one will rise faster than the other. What does it mean? It means one of them needs smaller heat to raise its temperature, while the other one needs more heat to raise the temperature. So the implication is simple. It simply means that the one that is rising fast, the one that temperature is rising fast, has a lower specific heat capacity or heat capacity, while the one that is rising fast, that is rising slowly, has a higher specific heat capacity. That's what we are saying. So you have to supply more heat to the one with higher heat capacity than to the one with lower heat capacity. So what is now heat capacity? That is why we are in this topic now. Okay, now the heat required to raise the temperature of a body by 1 Kelvin is called its heat capacity. But if we are considering a unit mass of that substance, that is now specific, because we are specifying it to just one of the mass, okay, unit mass. That's why we call it specific heat capacity, which means it is the amount of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin. That is specific heat capacity. I hope that is clear. Then what about heat capacity? Heat capacity has to do with the temperature of the entire mass. Okay, let's assume I have a stone or a metal and I want to heat up the entire metal. Okay, then the heat required to raise the temperature of the whole matter by 1 Kelvin or 1 degree Celsius is what you call heat capacity. Is that taken now? So the formula is simply H equals mc change theta. So C is the specific heat capacity. So we are now going into the next one, which is latent heat. What is latent heat? The word latent means something that is secret, hidden. As a science student, as a physics student, you should know, we should be learning all these things. The concepts are very important. When you say latent, it means something that is hidden. All right? You will notice that when you are heating water, let's use water because water is the commonest substance in our environment. When you heat up water, there's something you will notice. The temperature will be rising gradually, okay, from 0 to 1 to 2 to 3 and so on. Now, once this temperature gets to 100 degrees Celsius, do you notice that you are still heating the substance, but there is no further increase in temperature? If you like, take all the fuel in the world and heat up the water. The highest temperature water can record is 100 degrees Celsius. The question is, that extra heat, that extra quantity of heat, where did it go to? What did it do? What happened to it? Did it vanish? No. The question is no. The answer is no. Okay? The heat did not vanish. The heat is used to evaporate the water. Can you see that now? The heat is now, that extra heat is used to evaporate the water. The initial heat you use to raise the temperature is actually meant to raise the temperature. But once it gets to 100 degrees Celsius, any additional heat you put there will not raise the temperature, will not be detected by thermometer. It will help to evaporate or vaporize the substance. Let's call it vaporization. Do you understand now? Then you may be asked, what is the difference between boiling and evaporation? What is the difference? What does it mean for a liquid or a substance to boil? So what does it mean? So a substance is said to boil when its vapor pressure is now equal to the atmospheric pressure. If the two are not equal, the substance will not boil. It's not possible. Now, how do I make a substance to boil very fast? Do you see that now? So once you raise the vapor pressure, the substance starts boiling. Now, for a substance to boil faster, there are conditions for it. You have to find a way to reduce the atmospheric pressure. How do I reduce atmospheric pressure? If you go to a mountain top, for instance, the pressure at the top of the mountain is lower than the pressure at the sea level. So the higher you go, the lower the pressure, which means a liquid can boil faster when on top of the mountain, when heated on top of the mountain, than when it is down. I hope that is clear. So that is boiling. Boiling simply takes place when the vapor pressure of the substance you are heating equals the atmospheric pressure. Now, what is evaporation? Evaporation is simple. It's not boiling. Evaporation is simply the escape of molecules, more energetic molecules, from the surface of a liquid. Boiling takes place throughout the entire liquid, but evaporation takes place just only at the surface of the liquid. Now, let us differentiate between boiling and evaporation. Then I'll come back and differentiate between heat and what? Temperature. But let's look at boiling and evaporation. Boiling takes place throughout the liquid, throughout the mass or body of the liquid. Boiling takes place throughout. When a liquid is boiling, you just see the liquid, okay? You see the liquid jumping here and there. That is throughout the body of the liquid. But for evaporation, evaporation only occurs at the surface of the liquid. That is how evaporation takes place. So that is one difference between evaporation and boiling. Then evaporation takes place at all temperatures. Yes, all temperatures. Evaporation does not have a specific temperature. Or you can say evaporation occurs at 1 degree Celsius, at 2 degrees Celsius, at 3 degrees Celsius. No. Evaporation occurs at all temperatures. That is another difference. But boiling occurs at a specific temperature known as the boiling point or boiling temperature. Then evaporation can be affected by the physical environment, but boiling does not. Boiling point is 100 degrees Celsius, okay, or there's a point called boiling point, but there's no point called evaporation point. I'm sure you can see that. So these are some of the differences between boiling and evaporation. Do well to understand physics in this manner, and you will see yourself excelling. Just understand that there are the basic concepts in physics are two, and they are matter and energy. You can see that we are discussing energy, 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 and energy. So nothing else. We didn't discuss anything else. Then let's look at optics. Yes, optics is a topic that most students are scared of. A lot of students are scared of optics. Once they see optics, they are worried because we are not used to light. We are used to seeing physics as something that is very strange. You know, this there's this gap between what you study in physics and what it is in actual life, in reality. But that is not so. Okay, optics is a very simple topic. It has to do with light. Just know light, that is optics. Everything about light, reflection, refraction, interference, you know, these are some attributes, some properties of light. Because light is a wave. And what kind of wave? Electromagnetic wave. And it's also a transverse wave. I hope it's well understood. So light is a form of energy that activates our sense of sight. That is light. Now we have objects that can produce light, and we have objects that cannot produce light. Now objects that can produce light are called luminous objects. Then objects that cannot produce light are called non-luminous objects. What are luminous objects? They are objects that can produce light. What are the examples? Examples of luminous objects are the moon. Okay, the sun rather. The moon does not produce light. Okay, the light you see in the moon is the light from the sun. It's a reflection of the sunlight. That's what you see in the moon. So the moon itself cannot produce light. Please take note. Then we have the stars. Yes, the stars have their light. Okay, they produce their own light. Then we have fireflies. Yes, these three are natural sources of light. Then we have the artificial sources of light, which are the electric bulbs. Okay, electric bulbs. Yes, the source of light. Then we also have candle lights and the rest. So all of them are sources of light. I hope that is well cleared. Then we have reflection of light, where we talk about the laws of reflection and types of reflection. There are two types of reflection of light, two basic types of reflection of light. We have the regular reflection. I'm sure we are used to regular reflection. Then we have the diffuse or scattered reflection. Regular reflection means it follows an orderly manner. That's orderly reflection. It follows a particular direction after it has been reflected. While irregular reflection, which is random reflection, the light is scattered. Okay, the light is actually scattered when it follows that. Okay, once it follows it, it's scattered. So that is the difference between regular and irregular reflection. Please take note of that. Then don't forget the types of beams and rays of light. What is a ray of light? A ray is just a single path that light follows. That's what a ray is. So understand it that way. It's just a line, just a single path followed by light. That is just a ray. Okay? Then what is a beam? When you combine two or more rays together, what you get is a beam. So what is difficult there? Nothing. So students should understand this fact. It's very important. Okay? Nothing is difficult in physics. Physics is the easiest subject as far as I'm concerned. So you just have to understand how to navigate it, how to understand the concept of physics. All right? So that's the difference. Then what is shadow? Shadow. These are basic things you must know. What is shadow? A shadow is formed when an opaque object obstructs the path of light. That's simple. For instance, you know that you have a shadow. Why? Because you're an opaque object. Yes, you're an opaque object. Now the question is, what's an opaque object? You see the issue? So what is an opaque object? Now we have three types of materials based on the way they allow light to pass through them. We have transparent objects, we have translucent objects, and we have opaque objects. Transparent object allows a large amount of light to pass through them. So you can see objects clearly through transparent objects. Like the glass of the device I'm using now is a transparent object. Then we also have translucent objects. Translucent object allows only a fraction, only a small amount of light to pass through it. Okay, that's why it's called translucent object. Then we have the opaque objects. Yes, opaque means no object can pass through it. No light, rather, can pass through it. That's opaque object. So it does not allow any amount of light to pass through it. Okay, that's opaque object. Now, what is unique about opaque object is that since it is opaque, it forms a shadow. It blocks the direction of light. So when you have light and you place an opaque object, let me use a material here. Here I have a material. Okay, now I'm going to block it. You can see what's happening here. What do you notice? You see a shadow of this object is here, is right here, right? That's a shadow of the object. So what it means is that it blocks me. Look at my hand here. It's blocking the light rays. All right. So the implication is that the light rays have been blocked because it cannot penetrate my hands. So it has been blocked by my hand. My hand is an opaque object, so it has blocked the light rays. I hope it's well understood. Now that forms what we call shadow. So a shadow is a dark region, a dark region that is formed due to the obstruction of light or the path of a light ray. So that is what a shadow is. Please take note of this. This is very important. Then the laws of reflection and the laws of refraction. These are very important areas. Okay. Reflection means to send light or wave back to its original medium when it comes across an obstacle. That's reflection. Then refraction. Refraction is simply, what refraction is the bending of light rays. Okay, as it moves from one medium to another of different densities. If the two densities, let's say from one glass to another, if the two medium have the same densities, there will be no reflection. There will be no refraction. So light will just move straight from one medium to another. But because the densities are different, so when light is coming this way and it enters the medium, it will bend like this. But it will continue in the medium, but it will bend. That's exactly what we are talking about. I hope that is clear. So that is what it is. So try to understand physics in a very lighter way. Don't take physics to be too heavy in an examination if you want to do well, okay? Now, when you are reading physics, don't forget the calculations, the formulas. The expressions are, physics has a lot of formula. So do well to subscribe so that you don't miss my next live stream or next video. I'm going to make videos and live streams on all these topics I've evaluated or looked at or summarized in this live stream. So I wish you all the best. I do hope you subscribed and you did not just go away, you subscribed. So I'm happy that you watched and you have actually benefited something. So thank you very much for watching. Share the video to others when it has been made to come alive. Thank you very much. I will see you in my next videos and live stream. Do well to check out my other live streams too and videos. And don't forget to reach me, okay? DM me through my WhatsApp number. Thank you. I'll see you in my next video and live stream. And for now, goodbye.